welcome to this video. In this video, I've got yet another projector light, LED light. You can see it here. A friend just brought this to me, or brought this to my attention. It's got some components missing off it, so I'm going to try and replace the missing components if I can find them, and then see if I can get it working. As ever, give me a thumbs up, like, help this channel grow. It is growing. I'm thankful to all my subscribers. Here's the LED lamp, and there's a few components missing, I've noticed. So here I've got a capacitor missing, one of these little SMD capacitors. Here is a thermistor missing. Here is a bridge diode missing. And here is a little fusible resistor missing. So the plan is to, I don't know if I can show you this on camera. Try and keep a steady hand here. But these are marked. I think you can get a good view there. So I've got capacitor 3, is it? Capacitor 2, capacitor 1. 2 and 3A, so I'm guessing these are the same value. So I'm going to measure this and then stick the same value on there. Here there is the bridge diode is missing. So you can see AC here and plus minus DC outgoing there. So get a bridge diode here, recovered one of course. Here was a thermistor. I've actually got the bit of thermistor left over, but that's where it went. So I'm going to stick a different thermistor in there. And then these resistors are current limiting. And then we've got an ordinary fusible resistor here. And in fact, it says on here F1, fuse 1, I guess. And then what? Resistor 1, resistor 2, RR1 and RR2. There we go. So thermistor or variable resistor. Yeah, VR1. There was a thermistor in here, but so we can put a variable resistor in there. Something that'll handle over 240 volts. And here we are. And that's all I can see that's missing. So I can't see any of the lights broken, but we'll test those with the LED tester. If you haven't seen that video, how to make that, it's on the series there. How to make an LED tester series 1 to 4. So we'll get on with the testing. Got my LED tester plugged in here. Let's see if we can get some power out of things. So if you look on this, we've got plus and minus. I can't see which is which actually because I haven't got my glasses on. So I'll quickly pick up my glasses because I can't see anything without them. See this figure out which is plus and which is minus. Okay, so this is plus here. And if you look, you can see the trace running off it up here. And there's the minus there. Wonder if this will give us light. No. Oh, it will. There we go. So that's, if I zoom out a little bit, I'll try to zoom out. Oh. Like that. So you can see here, if I put this plus on here and this minus on here, it gives us these lit up. You can see a plus coming in through this circuitry in here. I guess that's it there. There we go. And minus. And if we go further down, probably get the other light as well if they're not broken. Oh, they're a bit weak, but oh, there we go. There we go. So they're all lighting up. It's a bit difficult to see it in this light on the camera. Oh, there we go. You can have a little play. Look, and there's that off. There's that off. There's some in the middle. There's some in the middle. And there's those. So nothing seems to be broken on the LED side. A good indicator of LED is broken. There's be a black burn mark in the center of them, or a brownish black burn mark in the center of each LED that's broken. I can't show you one because I haven't got one here. So next thing I guess is to find a suitable bridge diode to put into here. So let's do that. So here is an old TV receiver thing, you know, for these Freeview or satellite TV. And there's a bridge, nice bridge diode in there. That's for coming from 240 volts. So we'll take that off and put that into place. So switch on the hot air gun here. It's a bit noisy. It only takes a few seconds to warm up. If anybody's interested in that, I'll do a video on it if somebody leaves in a comment. If not, then I won't. So here comes the air. So I can remove this thing. And there it goes. In a second. And also on here I see we have varistors. So I'll probably take out this varistor here and put this one onto the board. Is it a varistor or is it a capacitor? It's a capacitor, not a varistor. We have a varistor down here. So there's a varistor here. So I'll take that off in a second. So here's the little bridge diode. Get this on camera here. Okay, here we are. There's a little bridge diode. That is going to go into here, into there like that, and then I've got a varistor here. So it's a TVR 1024. Again, it's recovered, but that'll go into there. And then it's a case of finding a capacitor to go in there and a fuse along there. So let's get those in place. So to attach this varistor, this doesn't lay in here so good, so I'm going to cut this leg off here. Keep this on camera, difficult. And I've lost my glasses, as usual. It's not going there like that. So we need to get some solder in here on these. So a bit of flux. Like I say, I'm working without my glasses because I've lost them. So a bit of solder in there and a bit on there. So add a bit in. Like that. Add a bit in there like that. And we'll put in this, try and put in this varistor into here. Like done. The other leg's not quite caught there. It was incredibly difficult to do without my glasses on, and they've vanished. So oh, sorry. So that seems to have got that. Well, now it's going to get in the way of the bridge diode. Great. So I'll put that. So let's move that around in another direction. So that'll be better. Or will it? Okay, so we can go in like this. That one can go in like that. And this leg can go on like. that. A good dollop of solder onto there. I think we've got good contact there. So I just tied it up by snipping off the bits of leg. And that's our varistor in place. So now to find, or to put in the bridge diode. Well, the bridge diode that I selected is a little bit small for this footprint. If we can find where. It's a little bit on the small side. So I'm going to try and find a better one than that. So to put this in place, as it's too small, I'm using a bit of, I'm going to use a very fine soldering iron with a very high temperature to get a good contact, hopefully. As you can see, it's incredibly finicky, if that's the right word, to do this. But perseverance is the key here. It's got one end on. Then it's a case of making a solder bridge here to the little legs. Which is it's a bit bubbly. But beauty is not what I'm striving for here. I'm striving for getting good continuity, good contact. That's all. Sometimes helps when you're doing this to get a bit of extra flux in on the job. Make the solder flow a bit better. Of course, I don't recommend you doing this at home or anywhere, because this bridge diode is a bit underrated, but for the sake of this video, I'm going to pursue it. So I think that's got it on in place. I'm sorry if I got a bit of that off camera, but it's particularly finicky. So to test it, make sure I've got it connected in properly. So get the multimeter and set it to continuity mode. When I can find the other end of the multimeter, here we are. Switch it to continuity mode. Oop. We can get continuity here. Here we have. So I can put this on here and see if we get continuity between. Yes, we have. And here. Yes, we have. Now this trace comes up to, a bit of solder doubled on there. Up to this trace comes up to here. So I put this on here, and the other end on the, I'm trying to keep this on camera here. It's on here. The other end right on the leg of the diode should get continuity, and we do. And then on this trace, on the end of this resistor here, I can get a good spot, and then onto the other leg, without touching the solder, obviously. Yes, and I'm getting good continuity. So that means the bridge diode is firmly held in place. So that's the bridge diode, the varistor. Now with these bridge diodes, these tiny ones, make sure you get the plus and the minus and the AC on the right way around. The AC is coming in here, DC is coming out here. So, or the rectified AC is coming out here. So a plus minus here, AC there. You'll see it on the bridge diode. I've got a pen here. On the AC side, it's got like an AC symbol. On the DC side, it's got a plus minus. So I guess next thing to do is find the capacitance of this here. I don't know what it is, but I'm suspecting it's the same as. So next, to find the capacitance of this little capacitor here, it's SMD capacitor, and I've brought in my Mastec LCR meter. So I'm going to change the function of this to capacitance DQ ESR in serial or parallel mode. I want it in so I can see the ESR as well, and the frequency I'm going to stick up to 100 Hertz. And then these little pincers here to put onto the capacitor. See what we get. So 327 nanofarads. Let's just have a look at this other one for interest's sake. 5.4 millifarads. So this one we're looking at 327 nanofarads. So I guess it's find 327 or 330 nanofarad capacity. So found one at 300 nanofarads, which is near enough. It's this one here. So I'm going to try and remove that with some hot air. And off it comes. There it goes. So now put this into the place of the one that's missing from here, for whatever reason, who knows. So I'm just going to add in a piece of copper wire as a temporary fuse, just to test it, see if it comes on or not. And I don't recommend you do this at all. Obviously it's at full mains voltage, whatever that happens to be in whichever country you're viewing this from. But here it's around about 220 volts. But this will act as a fuse temporarily, just as a tester. If I can get it to solder in place, that is. Oh, my apologies if I keep hitting the camera. It's actually my telephone. Get a better joint there. Okay, so that's put in place. So I guess the thing to know is switch it on as if it works. Obviously I can only switch it on for a few seconds if it is working, because it would be attached to a case that acts as a heatsink, and as I don't have that case here, it's just a case of for a few seconds. If it does work, then I'll put a fusible resistor in here at some point, maybe 10 ohms or something. So let's give it a try. This is test one, see if it'll come into life, or it goes bang with a puff of magic smoke. Let's see what happens. And nothing. So on further investigation with the multimeter, I found there's no voltage coming through. And I found that this contact here is lacking in contact. So let's bring this, give it a better contact. That's better. It's fixed in. Let's see what happens this time when I switch it on, if anything. And here we have power. Oh, shit. So after the little explosion, I had an investigation. It blew both of these resistors here, fusible or current limiting resistors here. And I thought, well, why? So then I thought, what am I doing? I've put a variable resistor across the terminals. A varistor. It should have been a capacitor. So I've got here a capacitor I've put in line in replace of this one, and I've just bridged these across just to see if we can get some light out of the thing. So I'll switch it on again, but obviously I can only switch it on for a few moments because it's not attached to its heatsink and I don't want to blow it up anymore. So let's try this time. And now I have success. So lesson learned there. Just because it had marked on here VR, I took that for a variable resistor, and it was a big mistake. I should have known better. How could a variable resistor be in there? It should have been a capacitor. There it is there. I put one in. That's 250 volts. Capacitance is very small, 400 nanofarads or something. So I guess now I've got to replace these two resistors and put a fuse in here properly. Okay, if you liked this video, then give us a big thumbs up. Please subscribe, help the channel to grow. It is growing. Thank you to all my current subscribers. I look forward to bringing you new content very soon. Thank you.